Here we are with Algebra 2, Assignment 04, so Unit 0, Assignment 4. And here we are being introduced to inverses. Before we get to problems and things like that, let me just quickly describe what an inverse is. Okay, so if I have a coordinate of something, so let's say I have a coordinate that is at 3, 1. All right, so there's an x and there's a y. So the x coordinate is 3, the y coordinate is 1. What an inverse is this exact same point, however, the x becomes the y and the y becomes the x. It doesn't turn negative or something like that. You don't change what the number is. It's just the x becomes y and the y becomes x. So the inverse of 0.31 would be at the point 1, 3. So 1, 3. This would be the inverse of that point right there. That is what the inverse is. So an inverse very basically is the x's become y's and the y's become x's. The x's become y's and the y's become x's. And more advanced, if you kind of know what I'm talking about, it might be not. If x is defined as the domain of something, and y is defined as the range of something, okay? X is the domain, y is the range, and I take an inverse of that. Okay, and so here is so notation is this. This is an equation. This is an inverse. All right, so here, x is still the domain, y is still the range. However, notice what happens here is that from the original, its range is now the inverse's domain, and the domain is now the inverse's range. Okay, so they are one and the same when it comes to this. Again, if you don't know what I'm talking about, that's fine. We'll need to kind of talk about this a little bit deeper, but I think there's a test question that is something similar to that. That's why I kind of want to give you the heads up about that dude right there. Anywho, let's get back to finding inverses. Now, how the heck do I take an inverse of a straight up picture? Well, easy peasy, that's how. All I do is I just kind of look at this picture and I pick out some points that kind of help describe what this picture looks like. Okay, so I just kind of go along there and I pick out points that might be important or that I know a little something about, like I pick out that point right there. So just some rando points. Okay, and I'll pick out that point as well. All right, this is kind of overkill, but okay. So right now, let's go ahead and label what these points are from left to right. So the very first one, I'm talking about that point right there, is at negative 1, 2, 3, 4, 5, 6. So that's at negative 6, 1, 2, 3, 4, 5, negative 5. Approximately, that's where it is. Okay, the next point is at negative 2, negative 4. And that's, I'm describing that point right there. Okay, the next point from left to right is the y-intercept right there, which is at 0, negative 3. Okay, the point after that is that point right there, which is at 1, 0. After that, right there, that's the point, and I'm talking about 2, 1. And last but not least, I'm talking about that dot right there, and that's approximately 6, 2. Okay. Oops. Drop my eraser here. Okay. So these are the points describing this picture. And we are to graph the inverse of this. All right, so what I do to graph this inverse is I just take the inverse. So x's become y's, y's become x's. So this would be -5, -6, -4, -2, where the y coordinate is now the x coordinate is now the y coordinate. So this comes to -3, 0, 0, 1, 1, 2, 2, 6. Oh, and it's worthwhile to note that an inverse picture will look very, very, very similar to the original. Now, it might be flipped around and rotated a little bit, but the rough picture is still going to be the same. This is going to be a squiggle S kind of shape. You know, it's going to be a squiggle kind of shape. It's not like it's going to really look something crazy different. It's not going to look like that or some crap like that. No, the general shape is going to remain the same. Okay, here we go. -5, -6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. -5, -6. Check. -4, -2. 1, 2, 3, 4. 1, 2. -4, -2. Check. -3, 0. -3. 1, 2, 3. Check. 0, 1, 0, 1. Check. 1, 2, 1, 2. Check. 2, 6, 2, 6. 1, 2, 3, 4, 5, 6. Check. There it is. So this is our inverse. So the picture started with this dot and went to that dot. So what we do is just connect the dots, and then intuition would probably imply that it goes on forever. Okay, let's go ahead and pick out some dots. Again, this is probably a little bit overkill. You probably don't need that many dots. But again, I really want to hammer the idea home on how you can do this. If you want more dots, you can take more dots. Doesn't really matter. So here we go. So we have -3, -6. We have -2, 0. We have 0, 3. We have 3, 0. We have 4, kind of like -0.5, kind of. We have 5, 0. And we have 6, 2. Okay, so those are the locations of those points, x's and y's, going from left to right. All right, so taking the inverses of this, this would be -6, -3, 0, -2, 3, 0. Again, x's become y's, y's become x's. 0, 3, -1/2, 4, 0, 5, 2, 6. So we have -6, -3, 1, 2, 3, 4, 5, 6, -3, 0, -2, 3, 0, 0, 3, -0.5, 4, 0, 5, and 2, 6. Okay. So again, it started at this dot and it zigged and zagged, and so it'll probably continue on in those directions. Again, when I made my points, I started with this dot, and then I went to this, and then this, and then this, and then this, and then when you draw your picture, start where your original start dot is, and then just again go to each one of those dots individually, and you'll pretty much construct your picture. Because if you're looking just at a flurry of dots, okay, you're just looking at a flurry of dots, sometimes it might be confusing on which direction you go. Like if I just have these dots, now do I do something like this? You know, like I don't know what that picture is. And so because I didn't follow the order in which I constructed them. So what I'm saying to you is this. I started with this dot, so start your picture there. And then I went to this, then I went to this, and then I went to here, 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 here. And then it pretty much draws itself. Just kind of like playing connect the dots. So don't mess up the order in which you found your dots. And don't take some rando order. Like don't be like, oh, here's a dot, and then here's a dot, and then here's a dot, and then here's a dot. Don't take a rando order. Go in order from like left to right, something like that. Okay, so the leftist dot that I have in this particular problem is 1, 2, 3, 4, -3. Then I have -2, 0. Again, go in order, left to right. And then I have 2, 2. And 6, 3, just a little bit over 3. Call it 3-ish. It's just a little bit above 3, actually. All right, so those are the original dots. I'm asked to graph an inverse of this. Oopsies. Okay, so that implies that this is going to be -3, -4, 0, -2. X's become y's, y's become x's. So this is like that 3-ish, so 3 plus, just a little bit over 3, 6. All right, so again, go in order. -3, -4, 0, -2. 1, 0, 2, 2, and 3-ish, 6, a little bit above 3. And notice how this original had a hard start. Like it doesn't go through it. It has a hard start at that point. So make sure you progress from that dot directly and not go through it. Okay, here there's a couple different ideas that you can follow. This is called an asymptote right here. And you probably don't really know what that is, but it's a line that you usually don't cross. And that is all at y is equal to 0. So I'll kind of use that as a reference. Okay, let's go ahead and pick out some points that are generally true. So I can use this guy, because that guy, and that guy-ish. Okay. So where we have tentative points are approximately -6, 0, 0, 1, 1, 2, and 2.5, 2.5, 6. Okay. Inverses means my dotted uncrossable line is now going to be x is equal to 0, because again, y's become x's, x's become y's. This point goes to 0, -6, 1, 0, 1, 6, 2.5. Okay, so the uncrossable line is now going to be x is equal to 0. Change colors here. we have a tentative point at 0, -6. Have a rough point at 1, 0, at 2, 1, and it's really getting out there at 6, 2.5. Out 6, up 2.5, and this is the general picture. All right, this one's pretty easy. To make a line, all you need is 2 points. So I see that we have what, -3, 0, and 0, -2. There it is. So I have a vertical line at -2. I have rough points at -2, -6, -1, 0, 0.5, 1, 1, and 6, and just a little bit short of 2, just a little bit shy of 2. So that means I'll have a -2, -6, -2, 0, -1, 1/2, 0, 1, 1, and a little bit shy of 2, 6. A little bit short of 2, 6. All right, so the uncrossable line in this situation is y is equal to -2. I have definite points at -6, -2, 0, -1, 1/2, 0, 1, 1, and 2, 6. F and G are inverses, true or false? I don't know. To do that, what I'm going to do is I'm going to pick out some points that I see that are on F. And all of these points have to exist on the G equation. All of these points have to exist on the G if they are indeed inverses. So the F, I see that I have, what, -6, +4, -3, +3. I have 0, 2. I have 3, 1. And I have 0, excuse me, as you were, 6, 0. Okay, so these points have to be on G. So I have to have the point for -6, 3, -3, 2, 0, 3, 1, excuse me, as you were, 1, 3, and 0, 6. These have to be on the equation G. Let's see if that is true. So I have the point for -6. Uh-oh. 3, -3. Uh-oh, not looking good. 2, 0, 1, 3, and 0, 6. This is the inverse of F. Notice how that is not G. So F and G are inverses. That's false. They have to be the same points, or inverse points. All right, so again, let's do that same trick. Are these inverses? So I'll look at F. I'll pick out some points and see if they exist in the same idea that G does. So of the F, I have points at 0, 4, at 1, 3, I have 2, 0, and I have, what, 3, negative 6. All right, so these inverses have to exist on the G. So that would be a 4, 0, a 3, 1, a 0, 2, and a negative 6, 3. Let's check it out. So we have 4, 0, 3, 1, 0, 2, negative 6, 3. That is the same thing. Hooray, they are the same. So yes, they are inverses. That statement is true. Okay. It says that given that g of x is the, again, this means the inverse of f of x. Okay. So g of x is the inverse of f of x. So right now, let's take a look. So f, again, this is the coordinate y in essence, and f of x is a coordinate y. So f has the points negative 3, 5, 0, 2, 1, 7, 4, 4, and 7, negative 3. Because those are the x and the y coordinates of the f function. So if I were to take the inverse of these, that would imply that these points would be 5, negative 3, 2, 0, 7, 1, 4, 4, and negative 3, 7. So that is the list of points that are the g of x, which is the inverse of that f. Okay. Now, 10 is a little bit tricky. It's not crazy tricky, but it's a question that is asking, is f and g inverses? Okay, so again, let's go ahead and take a look at the points that are on f. Let's take a look at the current points that are on f. So if I have an x of negative 4, I have a y of 4. Okay, and that's that one right there. The x is negative 4, the y is 4. The x is negative 2, the y is 2. The x is 0, the y is negative 2. 2, 0, and 4, negative 4. Okay, let's go ahead and take the inverse of these f's. So the inverse of these f's would be 4, negative 4, negative 2, 2. Actually, no, that one's completely wrong. I'm sorry. 2, negative 2. Negative 2, 0, 0, 2, and negative 4, 4. The x's became y's and the y's became x's. Now, I'm going to write down right now the points that are on G. So G, when I have an x of negative 4, the y is 4. X of negative 2, the y is 0. 0, 2. And again, what I'm doing is this. I'm like taking the x and I'm matching it up with its corresponding y, but rather of the G equation. 2, negative 2, and 4, negative 4. All right, now, at first inspection, you might think, "When these are not inverses." I mean, because take a look at that. That is not the same thing. All right, you might think that. However, these are indeed inverses, and here's how you show it, and here's how it's showing evidence that it is. All of the points match up. All of the points match up. Now, they might not come in the same order, but if the inverse of f is on G and the inverse of G is on f, then it's cool. Because notice that those match up right there. 2, -2, right there. -2, 0, you betcha. 0, 2, and -4, 4, you got it. So there are the points that are the inverse of f that are on G. So it doesn't really matter what order they come in. You can write them down in whatever order technically that you really wanted to. But as long as they do contain the points. So are these inverses? Yes, they have the inverses of each other. So this is indeed true. Yes, they are inverses.